for this problem, I want to rewrite the denominator and say this is the sum as n goes from 1 to infinity of n plus 1 over n times n to the 1/2. So in the denominator, I'm going to use the rules for exponents and write this as n to what power? 3/2. So n goes from 1 to infinity of n plus 1 over n to the 3/2. I'm going to use a comparison test. And I'm looking at the highest power in the numerator and the highest power in the bottom, n to the 3/2. So I'm going to compare this, compare it to the series as n goes from 1 to infinity of n over n to the 3/2, and that will reduce, n goes from 1 to infinity, that reduces to 1 over n to the 1/2, which does what? Converge? Diverge?
Converge. Because p is less than 1.
Diverge, right? Since p is less than 1, p series converge if p is greater than 1. If p is less than or equal to 1, it diverges. So this one diverges. So my hunch is that the one from the book is going to diverge as well. I'll either use the first comparison test where I would need that inequality, or I will use the second one where I can do the limit comparison test.
Do you have to show evidence that the two functions grow at the same rate?
Or that you mean that one is bigger than the other, or okay.
Two functions grow at the same rate.
But do they? The first one has that plus 1 in the numerator. That might mess that up a bit. Okay, so here, let me write this. To use the comparison test, the comparison test that we just called the comparison test. To use the comparison test, we would have to know that, well, that this one diverges. We'd have to know that n plus 1 over n times the square root of n is greater than 1 over n to the 1/2. And in my head, I'm thinking, is it greater than or equal to? Greater than or equal to? So I'd have to have that to use the first one. Let's see if we have that. Well, I can multiply both sides by the LCD. And I have to be careful maybe about this. I'm going to multiply the fraction on the left by, what is the LCD, by the way? N times the square root of n. And then that's greater than or equal to, and I'm being a little sloppy here. So let me clean this up. I'm not saying that this inequality is true. I'm questioning it. So let me put those question marks, because just writing it, I might be writing something that's false. On the left side, these reduce. Oh, and the n reduces. And here, these reduce. So this is what I end up with. Here's the question. Is n plus 1 greater than or equal to n? Yes. So I have the inequality I need to use the regular comparison test. And then I can say Well, they both do the same thing. Because the one I'm using to compare it to diverges, I know if the one I'm looking at, the A sub n's are greater than or equal to the B sub n's over here, and they are, then I know that the one I'm looking at also diverges. Here, I'm going to put this in up here at the top here. That's what I'm looking for. And I called this one B sub n. The sequence part of that one's B sub n. The sequence part of this one is A sub n. I got the inequality, so I can say this. By the comparison test, the series, the sum as n goes from 1 to infinity of n plus 1 over n times the square root of n diverges.